All right, 6.2, solving exponential equations using properties of exponents. Okay, so all of these problems have to do with this one fundamental idea, and that is that if you have an equation where your bases are the same but your exponents are different, as long as the bases are exactly the same and you just have one base on either side, therefore the exponents must be the same. So the goal here is to get it so that the bases are exactly the same. So let me show you what I mean by that. Let's take a look at example number 1. Right now, this is a base of 2, this is a base of 64. We want them to both be the same. The easiest way to do that is usually to make them both, or make the one that's bigger, rewrite it as a base of 2. Sometimes you're going to have to change both bases, and we'll get to that. But let's just first think about this. I can rewrite 64 as 2 to a number. All right, and so you might have to think about what that is, but 64 is the same thing as 2 to the 6th power. You can check your calculator real quick if you want, but 2 to the 6th power is 64. So since it's equal, that means that we can actually just rewrite this whole equation as 2 to the 3x minus 7 equals 2 to the 6 to the x power. Well, last video we already talked about how if you have an exponent inside the parentheses to another exponent, that's just like multiplying the exponents. So we can actually rewrite this as 2 to the 6x equals 2 to the 3x minus 7. At this point now, notice the bases are the same. If the bases are the same, then the exponents are the same. And so I can just go ahead and write this as 3x minus 7 must equal 6x. And now we're dealing with simply a linear equation, very simple to solve. I'm going to subtract 3x from both sides. Which gives me negative 7 equals 3x, and then divide by 3, and I get x equals negative 7/3. That is my answer. And don't get scared if you get a fraction. That's okay. Fractions are okay. They're fine answers. So again, let's just recap. I first made it so that we had the same base. I had to think about how can I write that with a base of 2. So knowing your exponents is going to be helpful here, but you also probably want to have a calculator. You could just try. You could try 2 to the 4th, 2 to the 5th, 2 to the 6th until you find the one that matches. And this one, it was 2, and then from there we got them the exponents equal, and we were able to solve. So what I want you guys to do is try to do something similar with practice number 1, but I'm going to start you off with it because it's a little bit tricky. You might notice that 27 could be written as 3 to an exponent, but this is 1 over 27. So let's recap here just a little bit. 3 to the 3rd power is 27. But what if I want it to be as a fraction, or I want to think about how I could write this as a fraction? Well, it turns out, remember we've talked about this before, that negative exponents are reciprocals. So if 3 to the 3rd is 27, then 3 to the negative 3rd is 1 over 27. So you can write this whole equation as 3 to the 5x plus 4 equals, instead of 1 over 27, I can write it with a base of 3 and an exponent of negative 3, and then an x minus 2 here. I'm going to let you try and finish this one on your own. So pause the video, give it a chance, and then check back when you're ready to check your work. All right, so the first thing we did, like I did with you, is we rewrote this as a base of 3. So now I have negative 3 inside the parentheses as an exponent, and this x minus 2 is an exponent. So I need to distribute this. I can multiply it, so I need to distribute it. That gives me negative 3x, and negative 3 times negative 2 gives me positive 6. Now I have it written so that my bases are exactly the same, therefore my exponents are the same. So I set those equal, just did some algebra, and I got down to x equals 1/4. Okay. Let's go on to the next problem here. All right, so this one's a little bit different in that now I have 3 terms. Before I was just dealing with 1 term on each side, but now I have 2 over here and 1 over here. So again, I want to get them all to be the same base, and then I'm going to write this with just 1 term. So first, let's get everything with a base of 3. That's the easiest way to do it. It's also a possible way for me to get this to be, I noticed that these are both 81, and there's something that I know about 81. I actually know, you could play around with the calculator here, 3 squared is 9, 3 cubed is 27, and 3 to the 4th is actually 81. So there is a way to do this so that you can actually take a 4 out of here, because these both have a 4 in it, and write this as 81. That's one way to do it, but I'm gonna show you what I think is a little bit easier for a lot of you guys to understand, and that is to actually just make these write these as 3s. All right, so first let's just do it with everything written as a 3. So this is 3 8x minus 4, and we already said that 3 to the 4th is 81, so then that means that I can write 81 as 3 to the 4th to 2x minus 8 equals 3 to the 4th as 9x plus 1. So let's write it all so that I have just bases here. So I have 3 to the 8x minus 4. And this 4 inside here needs to be distributed to everything up here. So I would write this as times 3. 4 times 2 is 8x. 4 times negative 8 is negative 32 equals, and I have to distribute this 4 as well. So this is 3. 4 times 9 is 36x. 4 times 1 is just plus 4. Okay. All right, now I have all the same bases. That's nice, but I still have something I have to do here. I have to have just one term. Right now I have 2. Well, we learned that if I have the same base, I can add the exponents. So I actually can write this as just one term, and I could add the exponents. So 8x and 8x makes 16x. Negative 4, negative 32 makes negative 36x, or just 36. And so now I finally have it so that I just have one term on each side, and they both have the same base, which means then that these exponents must be equal. So let's go ahead and solve that. I would write 16x minus 36 equals 36x plus 4. I think that I want to subtract 16x. Let's do this in red. Subtract 16x, subtract 16x. And I'm going to subtract 4, subtract 4. That would cancel, and that will cancel. So 36, negative 36, remember that's a negative 36 and negative 4. That's going to make negative 40. And 36 minus 16, that's going to be 20x. So I'm going to divide both sides by 20. And I get that negative 40 divided by 20 is going to be negative 2. So I get that x equals negative 2. Okay. Lots of little tricks there, lots of little work that we're going to do. I knew my properties of exponents, and that allowed me to simplify all the way down to here. From there, my exponents are equal, and then I'm just doing some basic algebra and solving. So got to be fluent in those properties of our exponents in order to solve problems like this. Go back to 6.1 if you're having some issue with those. There's some properties on there that you just basically have to have memorized. All right, practice number 2. I'm going to help you guys get started on this one, and then I want you guys to be able to finish it. I'm noticing that there's a 2 as a base, a 2 as a base, and this one has a 16 as a base, but I'm pretty sure I can write 16 with a base of 2. Think about it. 2 squared is 4, 2 cubed is 8, and 2 to the 4th is 16. So that means you can replace that with a 2 to the 4th. So you could write this as 2 to the 4th in parentheses to the x plus 5 over 2 to the 7x plus 2 equals 2 to the x minus 2. And then furthermore, I'll do this with you. We can distribute that. So this should look like 2 to the 4x, and 4 times 5 is 20, over 2 to the 7x plus 2 equals 2 to the x minus 2. All right, I want you to finish it from here. But remember, you have a common base here, and you need to get this all to be one term. So that means you can actually, there's a rule that you can do with these exponents when the bases are the same and you're dividing. I'm going to let you try and figure out the rest of the problem on your own, and then check back when you're ready to check your work. Okay, so the rule that I was hoping you would recognize is that when the bases are the same and you're dividing, you could simply subtract the exponents. So 4x minus 7x is negative 3x. 20 minus 2 is 18. And so now you can write it as just one term with the same base on each side. So that means that your exponents are equal. So I just set the exponents equal, did some algebra, and I solved and got that x equals 5. All right, let's go ahead and jump to example number 3. And it says here that sometimes we need to change the bases of both sides to get a common base. Yeah, so right now, there's no way to write 16 really to get to 64 or vice versa, but we can write both of these as 2. So if you remember, 2/3 is to the 8, or 2/3, 2 to the 3rd is 8, 2 to the 4th is 16. So that's like 2 to the 4th. 2 to the 5th is 32, and 2 to the 6 is 64. But these are not just 64 and 16, they are the reciprocal. So we're going to need to use 2 to the negative 4th is 1 over 16, and 2 to the negative 6 is 1 over 64. So that's how we're going to start. I'm going to replace the 1 over 64 can be replaced with a 2 to the negative 6, because we already said that that's equal. And then I have a negative 2x plus 4 out here, equals, and 1 over 16 can be replaced with 2 to the negative 4. And that's to the 5x plus 2. All right, I need to go ahead and distribute these. So I would have 2 to the negative 6 times negative 2 is positive 12x, and negative 6 times 4 is negative 24. And over here I have 2, negative 4 times 5 is negative 20x, negative 4 times 2 is negative 8. All right, now my bases are the same, and so my exponents must also be the same. So I could just do some algebra here. I got 12x minus 24 equals negative 20x minus 8. I would start off by adding 20x, and I'm going to add 24. That cancels, so 12 plus 20, that makes 32x. 24 minus 8, that is 16, divide both sides by 32. 16 divided by 32 is 1/2, so we get that x equals 1/2. All right, pretty easy just doing some basic algebra once I get the exponents equal to each other. Last one here, this is for you guys. Remember, you're going to have to probably change both bases, so think about how you could change both of those bases and then be able to set the exponents equal, and then check back when you're ready to check your work. Okay, so 8 can be written as 2 to the 3rd, 4 can be written as 2 squared. So once you rewrite it, then you just have to distribute this 3 to here, so you would get 3 times 3 is 9x, 3 times negative 7 is negative 21, 2 times 6 is 12x, 2 times negative 1 is negative 2. Now you have the bases are the same, therefore the exponents are the same, so I set the exponents equal, and then I just did some algebra, and I get x equals negative 19 over 3. Okay, that's all there is for this video. It's just a bunch of examples of solving exponential equations. See you guys on the next video.